Hey there, tech enthusiasts. Welcome back to TechGuru. Today, we are diving into one of the most powerful and versatile microcontroller series, the STM32. Whether you are a beginner, an embedded systems engineer, or an IoT enthusiast, STM32 offers cutting-edge performance and endless possibilities. What an MCU is? Simple definition of a microcontroller. A microcontroller, also called MUSI or MCU, is an embedded computer chip that controls most of the electronic gadgets and appliances people use on a daily basis. It is a compact integrated circuit designed to govern a specific operation in an embedded system. Point to microcontroller architecture. A typical microcontroller includes a processor, memory and input-output (I/O) peripherals on a single chip. Its components may be extended to include digital I/O, analog I/O, timers, communication interfaces, watchdog, a timer that is responsible for the detection of timed out or locked instruction. A processor is a little chip present in the device that has the role of arranging the instructions and order the outputs. The manufacturer defines the integrated peripherals and the hardware capabilities. This is the basic layout of a microcontroller. Point 3 STM32 Overview. Cent Microelectronics is manufacturing the STM32 MCUs, which are based on the ARM Cortex-M processor. They are 32-bit RISC-ARM processor cores, optimized for cost and power-sensitive MCUs. RISC-ARM, Reduced Instruction Set Computer, is an instruction set that allows to divide the commands into several, simple and not complicated instructions that are meant to realize small objectives. The STM32 family offers a large range of devices combining 1. Full integration. 2. Ease of development thanks to the large ecosystem and professional development tools including free ones. 3. Very high performance thanks to ARM Cortex-M core and Cent ART Accelerator TM for some families. 4. Real-time capabilities. 5. Digital signal processing. 6. Low power and low voltage operation. 7. Connectivity. 8. Graphic features. Several applications rely on STM32, to be detailed in next chapter. 1. Industrial control systems. 2. Human interface devices. 3. Smart metering. 4. Motor control. 5. Medical instruments. 6. Buildings and security, alarms, access control, power meters. 7. Consumer products, PC peripherals, GPS, gaming. 8. Internet of Things. 9. Connectivity. Point 4 Cortex-M architecture. The Cortex-M portfolio includes different architectures where the main ones embedded in STM32 microcontrollers are the following. Nested Vectored Interrupt Controller is used to organize the interruptions in order to reduce the suspensions. The Wake Up Interrupt Controller, WIC, is a way to detect an interruption and wake the processor from the sleep mode. Cortex-M comparison table, from ARM. STM32 features. Point 1 STM32 peripherals. Over the time, new peripherals are embedded to answer emergent requests on the market. The peripheral characteristics are not frozen. The very first STM32 devices are being improved to enable new features or fix some limitations. The peripherals like low power voltage detector, clock security system, CSS, and watchdogs help supporting safety critical applications. The code security may be ensured thanks to some protection features of the flash memory. Point to STM32 hardware setup. Power supply. It is required to power on your device to make it start working. Oscillators. The STM32 embeds an internal RC oscillator, but it is not accurate and stable as an external crystal. Debug. After programming the MCU, the next step is to debug the code, which means to reconsider it and try to resolve any defect that may interrupt the use of the MCU, and this is realized within a software program called debugger. While using a software IDE, a debugger is installed by default, but once developing the application of the MCU, a hardware debugger is needed. Depending on the supported debug system, it is possible to connect a debugger to the device, and here are two examples: SWD, Serial Wire Debug, which can be added using two pins. It is designed for micro debugging JAG, Joint Test Action Group, within 5 or 4 pins. It is designed for checking faults in boards in production. Point 3. STM32 Resources. A dedicated webpage is available on CENT website for each STM32 family. It contains all relevant documents and resources to guide the end user on how to start developing with selected STM32 device and exploit it in an efficient way for users' application. The main relevant documents are Datasheet, DS, the document describing the electrical characteristics of the product and its pinout. Errata sheet, ES, the document that specifies the known limitations of the product and the ways to work them out if available. Reference manual, RM, the document providing the product specification and describing its registers. Point 4. Varieties of STM32 MCUs. There are already 16 Cortex-M based microcontroller families or series. The STM32 families are split into 4 groups divided as follows. Family Core Max Frequency Flash High Performance STM32H7 Cortex-M7. Cortex-M4 480 MHz to 240 MHz 1 to 2 MB STM32F7 Cortex-M7 216 MHz to 56 KB to 2 MB STM32F4 Cortex-M4 180 MHz 64 KB to 2 MB STM32F2 Cortex-M3 120 MHz 128 KB to 1 MB Mainstream STM32G4 Cortex-M4 170 MHz 32 to 512 KB STM32F3 Cortex-M4 72 MHz 16 to 512 KB STM32F1 Cortex-M3 72 MHz 16 KB to 1 MB STM32G0 Cortex-M0 plus 64 MHz 16 to 512 KB STM32F0 Cortex-M0 48 MHz 16 to 256 KB Ultralow Power STM32U5 Cortex-M33 160 MHz 1024 to 2048 KB STM32L5 Cortex-M33 110 MHz to 56 to 512 KB STM32L4 Plus Cortex-M4 120 MHz 512 KB to 2 MB STM32L4 Cortex-M4 80 MHz 64 KB to 1 MB STM32L1 Cortex-M3 32 MHz 32 to 512 KB STM32L0 Cortex-M0 plus 32 MHz 8 to 192 KB. Wireless STM32WB Cortex-M4, Cortex-M0 plus 64 MHz to 32 MHz to 56 KB to 1 MB STM32WL Cortex-M4 48 MHz 64 KB to 256 KB. The STM32 portfolio continues to be extended with more integration and performance and more complex peripherals. All ones with generic or dedicated application field. The previous table helps to select the family of MCUs suitable depending on application needs, but it's required to review deeply the product characteristics and components to fine-tune the choice. And that's a wrap. STM32 is an incredibly powerful microcontroller family that's perfect for everything from embedded systems to AI and IoT. Which STM32 project are you excited to build? Let me know in the comments below. Don't forget to like, subscribe, and hit the notification bell so you don't miss out on future tech videos. This is TechGuru, signing off. See you in the next video.